Welcome everyone to this new Datadog episode. Datadog is a series where we invite engineers, designers, data scientists who are working every day on building Datadog itself to talk about a problem they're solving, a particular technology they're using, a product they're building. And today we are going to be covering one of those technologies that we're using very heavily here at Datadog, which is Apache Iceberg. This episode is going to be recorded, so if you have any colleagues who might be interested in this content and couldn't attend it live, it's going to be available as every other episode on our website on datadoghq.com. So check out in a few days and you will be able to see the recording there. But for those of you who joined live, this is great because one of the good things that we want to do with this episode is to get a lot of interaction from attendees. We are going to do some content, but then we are going to leave enough time for questions at the very end. So if you have questions throughout the episode, you don't have to wait until the very end to ask them. There is a Q&A button in your Zoom client. Just click on that button, leave the question there, and then we will cover them at the very end as much as we have time. So my name is Ara Pulido. I'm one of the co-organizers of this series. So if you have any feedback about the series, if you have suggestions about topics you would like us to cover, feel free to reach out on that email and I'll be happy to discuss. But the important people today are Leo and Alessandro. Leo, do you want to introduce yourself?
Yeah, so I'm Leo. I've been at Datadog for 3 years now. Kind of in different roles, starting first more as an ML engineer and as actual user of Iceberg, and then switching more recently this year to lakehouse team, which I now lead, and the lakehouse is actually providing managed Iceberg at Datadog scale.
Cool. Alessandro?
Yeah. Hey everyone. Yeah, so I'm Alessandro. I'm a software engineer and I started Datadog about 1.5 years ago. And yeah, I'm in the lakehouse team with Leo.
Welcome both, and thanks for joining today. So today we are going to cover that Apache Iceberg that we use, as we said, heavily at Datadog. And the first thing that I did when preparing this is like going out, Google what's Apache Iceberg in the first place, which I wasn't aware of. And the first definition that I got is it's an open source table format, which was a little bit ambiguous for me. Leo, do you want to explain a little bit what that means in practice?
Yeah, I can understand. So Iceberg is an open source table format, as you said, and what it means it's first a specification or actually multiple specifications that define how table metadata is structured, including like schema, partitioning, snapshot lineage, and the read-write semantics. Then you would have multiple query engines that implement that spec and leverage metadata for building query plans or write atomic transactions using Catalog, which there are multiple implementations from as well. That means mostly that you can pick the best engine for your use case, either doing Spark for large ETL use case, Trino for interactive analytics, or other vendors like Snowflake or Databricks that interoperates with Iceberg tables now. And you can keep your data stored in a single place that you would own and buckets that you would own. This mostly allows to optimize for operational costs and have easier dataset governance, having like data stored in a single place.
Great. It's like a many open source ecosystem where you pick and choose all the tools that you need for your job.
Exactly.
Good. So for those who are not that familiar with Apache Iceberg, what are the features of Apache Iceberg that you're mostly interested in?
So first and foremost, we were most interested in the SQL interface that the table abstraction provides. And along with that, compared to mostly his predecessor, Hive, Iceberg provides some asset guarantees. So to explain that, Iceberg gives atomicity on reads. That means that every query will run against an immutable snapshot and never see a partial commit. For writes, you will have writers that prepare new data and metadata file, immutable, then will require from the catalog a swap of the table pointer to point to the new snapshots and update the snapshot lineage. Iceberg commits are generally optimistic, so writer will assume that underlying data will not be changed by other process. If that happens, then your commit might fail, and on the client side, you will reconcile and retry at client level. And generally, the stricter isolation level depends on the actual engine implementation. And for instance, Spark supports serializable isolation that you have also in other databases. And mostly what it means is that checks will apply on concurrent append and updates in the same partitions. And typically, overlapping concurrent writers could commit to the same table without having data conflicts happening. What the snapshot lineage also provide is also real lineage and that you can go back in time. So you can go back to any snapshot that you want, and you have time travel query that can be very useful in the context of debugging or audit, or even if you want to have a stable data set in context of machine learning, that you can use things like tags to materialize a specific state that you'd be interested in. Then another very interesting feature is that historically schema or partition changes on table used to require rewriting data. With Iceberg, we reduce the migration cost by making this change metadata first. That means that column keeps table field IDs and column renames, append, or delete only affect the metadata first, and the logical field survives in the past data files. And the new change on the schema will only append the new data file per se. Partitioning has the same schema, so has the same scheme where like a given partitioning scheme will be bound to a partition spec identifier in the metadata file, and changing the partition spec might affect the new data layout, where readers will continue to query using the same logical predicates on the former layouts. And here in this slide, you have a brief overview of like how Iceberg metadata is structured. So first you have the Iceberg catalog, which is responsible for keeping the pointer on the metadata file. The metadata file is a tiny JSON that stores table schema, partition specs, and snapshots lineage. And a snapshot is really defined by a single manifest list file, which has a list of manifest files simply along with their related partitions. And each manifest will simply be like entries of data files along with their statistics, such as row count, partition values, and statistics and column values. And then the statistics are really what are key to engine querying performance. So whenever you're doing a query with Spark, for instance, it will traverse this metadata structure, finding from the manifest list only partitions and the manifest that are in the predicate of your query, and same from the manifest only at the relevant data files. So that means you really have to fetch minimum amount of files for a given query. But this metadata model, which is mostly immutable, also implies that you mean that you are to do some background maintenance to keep your metadata small, as we will explain later. And things like metadata and data file compaction is key so that you can keep consistent performance and consistent length of your manifests and data file.
Yes, maintenance is something that definitely we will be covering a little bit more in detail, because as I've learned while working on this, it's definitely critical. Great. Thanks a lot, Leo, for that overview. I think it's helpful for those folks who might not be that familiar. But I think now it's interesting also to talk about, now that we have like we are on the same page on what Iceberg is, let's talk about how Datadog uses Iceberg, because it's actually quite new relatively to other types of data management at Datadog, because traditionally at Datadog, we've been focusing a lot on this use case, which is obviously observability data.
Yeah, so totally. So to get back to the history of Datadog, like more than 10 years ago, it started with mostly metrics and APM products, and then was complemented with logs, then traces, events, spans, a variety of different resources to represent your infra as well. So there's a variety of different use cases and constraints, but mostly for observability data such as metrics or logs. You have really a high volume of events that are streamed. So it's a really high ingestion rate, and you want to have a really fast response time between and ingestion time between the data is being processed and the data when you can query the data. So all in all, that is very specific constraints where Iceberg don't really match those requirements. But on other use case, on the other hand, we could find some benefit of using Iceberg, as we will see.
Yes,
So,
because
yeah.
definitely our system were like having this specific use case and not so much the long-term analytical data that Iceberg is helping with.
Yeah, totally. So it's definitely more for the use case of batch and offline analytics first that it can be good. It can be covering other use case as well, even for interactive analytics query. But what really it allows us in the context of Datadog is providing some cross-dimensions and historical views of export of metrics or logs and doing some joins with like business or customer data. And have integration as well with our different query engines. And we'll see such of those use cases, but we have use case like defining audience from business attribute for A/B feature experiments or cloud pricing rate used by cloud management to name some of the business or customer data that we might want to join with.
Good. So yeah, let's see some of those use cases. So I guess the first one that I want to talk about is product usage and billing, and folks who might be here and already being Datadog customer might be familiar with this page where they can see, especially if they're an admin of Datadog, they're able to see all the usage from their Datadog usage alongside what that usage looks like and like how many infra hosts, how many PIM hosts, etc. So how does Iceberg plays into this view?
So Iceberg plays a key role here because we have like canonical tables where we store product usage, and that is being served to many different use cases. So you've mentioned product usage in billing that you directly expose into Datadog products, but we also have like team cost attribution with breakdown both customer selected tags or internal product analytics where we're also leveraging those tables. Upstream from those, we have basically two kind of different sources. One is around metering API, which product team calls directly to register their product usage. One other is directly from export from metrics or events. For instance, things like the number of hosts, the metrics that you could have exported and aggregated into usage table. Together, this produce either per resource or usage per base metrics. So for instance, the number of DBM hosts in an hour or the count of CI pipeline run. And the ingestion layer, they duplicate repeated observations, absorb late arrival data, or aggregate by different time granularities and segments the product cares about, emitting one row per org times fine and segment.
Great. So another use case that I wanted to talk about, which is actually pretty new, is a It's a brand new feature. It's in preview. So if you're a Datadog customer and want to give it a try, I'm going to give a link on the recording, which is real-time cloud cost. So Datadog released a couple of years ago Cloud Cost Management, in which you can, especially FinOps teams, are able to track all the costs of the different clouds. But obviously that data came a little bit delayed because Datadog had to wait for the data coming from the cloud themselves to aggregate all of that. But now that it's changing, they're actually releasing something called real-time cloud cost, which tries to give you more like almost real-time data of your cloud costs. How does that work, Leo? And how, especially how Iceberg works on this one?
Yeah, so maybe to give a brief overview of the difference of real-time cloud cost and cloud cost. Cloud cost is mostly based on the actual infra billing, whereas real-time cloud cost is based on mostly having metrics from your current state of your infra diagram and joining that with pricing data. So what we do is upstream, we have a real-time resource inventory that have the collection of your EC2 instances or Kubernetes pods with associated tags. We'll sync a snapshot of that into Iceberg table. And then Cloud Cost Management will leverage Trino to join the snapshots with unit price and compute per instance and per org aggregated costs. Aggregated results are cached in Iceberg, then emitted as real-time metrics that are emitted every 10 minutes for CCM customers.
Nice, very, very useful to be able to adapt and finding those peaks on usage. So let's finish with AI. I know your background is ML, so very close to your heart. So we are using Iceberg for training models. I put here the example of Toto, which is an open weights time series foundation model that Datadog releases about a year ago, and where obviously we use we have a lot of data that it's time series data coming from the usage of Datadog from Datadog, because we are like one of the heaviest users of Datadog ourselves. And use that to create this time series model that is able to forecast that time series data. Obviously, we are not going to talk about this particular how we train Toto, but how Iceberg plays a part on this, which is pretty critical.
So in the case of Toto, we're mostly using a large-scale extract of historical observability data, so mostly metrics, over 1 trillion of data points just for our own org, but like in historical span, and having some incremental pre-processing pipeline to do things like grouping metrics by name or tags and time spans. And this necessitates alone to train safely on large metric extract without really hitting the metrics prod services that are not really optimized for a batch. And also Iceberg integrates well with our ML tooling. So in the case of Todo, it's Ray and PyTorch that is being leveraged for ML training. Iceberg also provides schema governance and consistency, which is really generally a requirement in context of ML training. For next, we are also very excited to see evolution of open source data formats that are supported by Iceberg, and for example, have data formats that are optimized for GPU acceleration, and that could help really building those use cases more efficiently.
Nice. Cool. So thank you. Now we've talked about first what is Apache Iceberg, second how we use it, but now let's talk about the core of your team, which is managing Apache Iceberg itself. So how do we do it at Datadog, which is the core of this episode about Datadog on. So before we do that, Alessandro, if you can give us a little bit of the scale that we run this lakehouse.
Sure, yeah. Yeah, let me walk you through how you actually operationalize our lakehouse and like some of the architecture choices we made. So first of all, we began our journey with Iceberg roughly 2 years ago. but it's really only at the beginning, at the start of this year, that we saw adoption ramping up. So today we manage more than 50,000 production tables, storing petabytes of data. And on average, we see around 8 million scans per day. Yeah, so we're a platform team at Datadog, which means our mission is to offer managed Iceberg experience to our internal users. So the goal is teams don't need to replicate effort, and we can avoid the necessary friction in using Iceberg. And we have 3 main requirements that come directly from Datadog. First, we need multiple engine support. We have a wide range of internal teams and use cases, and they need to be able to choose the best tool for the job. So it could be Spark, Trino, or Ray, as before, but we have more. Then the second requirement is multi-cloud. So Datadog operates across all major cloud providers. So our platform needs to work everywhere with the same capabilities. And finally, we need to guarantee isolation across user environments. So we operate in a multi-tenant environment, and so we must prevent noisy neighbors and other problems, and security requirements, other problems that come from multi-tenancy in general. And since we deliver managed Iceberg as a platform, then our main areas of ownership include a REST catalog, automated maintenance for keeping the tables we manage healthy, and then finally table observability, because we are a Datadog, so we should monitor everything. But let me spend a moment just expanding on each of these areas. So the first one, REST catalog. But yeah, what is a catalog in Iceberg? The catalog is a key part of Iceberg. In fact, Iceberg needs a way to keep track of the tables by name, and the catalog primary role is to store a pointer to the current table metadata. There are several catalog implementations, but in the last 2 years, the community's focus has been around the REST catalog. So without diving into the alternatives, the REST approach offers several major benefits. The first one is decoupling the catalog implementation from the engine. So that making it easier to add Iceberg catalog support to new engines and languages, because now you only need to speak HTTP. Then it unlocks new features like multi-table commits and transactions and query plan caching. And then finally, I think the most important, in my opinion, is centralized and unified access control. So that means that authorization policies can be shared across engines, and we are sure that the same policies are enforced for every client, because every request goes through our service, basically.
Good. So basically all RBAC is implemented at the REST catalog side of things.
Yes. And we actually, we could spend more and more time talking about access control, because in Iceberg, we're dealing with access control on 2 levels, the catalog access control, but then we also have the storage access control, which Iceberg offers, like REST catalog offers a cool feature that is credentials vending. So you don't need to grant engines full access to your bucket, but the catalog can serve temporary and scope credentials to the engine. This is one way to do it.
Excellent.
Yes. So how our catalog looks like? So internally we use JDBC catalog, which another implementation, but it's behind the REST interface, which implements the REST catalog API. So it's not exactly the JDBC catalog that you'll find in the Iceberg repository. We made a number of improvements so that it works smoothly with the REST-based setup. And then in front of the catalog, in front of this of the REST catalog API, we added the gateway that handles authorization, and then we also need to satisfy some additional internal security requirements like MTLS. And then also something more that we added in the gateway is throttling, client quotas, things that we need to satisfy isolation across users.
Nice. So let's talk about automated maintenance that we we gave a hint. That was a big part of maintaining Apache Iceberg.
Yes, so maintenance is essential for Iceberg, especially for keeping tables fast, clean, and cost efficient. There are 4 main operations that we run regularly. The first one, and probably the most important, is expiring snapshots. So every time you write to a table, it creates a new snapshot that is used for time travel. But then these snapshots build up over time, and you need to expire the older ones to keep the metadata small and prevent catalog bloat. Otherwise, the size of metadata grows, and we actually, at the very beginning of our journey, we saw the impact on our catalog memory usage. The second one is delete orphan files. Deleting orphan files is not crucial for Iceberg performances, but it's something that you should run to clean up your object storage from files that are not tracked by Iceberg metadata. That can happen when like you're a writer that fails, and not always the files are cleaned up automatically. And then finally, there is compaction of data files and compaction of manifest. Compaction of data files almost include rewriting manifests. So, like say, compacting data files is more important, in my opinion. And especially for streaming workloads that we have, where we very frequently ingest small files, and those small files can slow down queries. So we need to periodically compact them into fewer and larger files. And yeah, so we run this compaction using scheduled Spark jobs on a schedule. Expiring snapshot, as I said, we need to run it more frequently because we have tables with heavy write volume. So they accumulate metadata very quickly. And as I said before, in the past, we faced memory pressure in the catalog. So because we were not running this fast enough. And then for compaction, we run it with less aggressively. And we, for now, we are doing beam packing on tables. And yeah.
So you touch a little bit on using Spark jobs to do this automated maintenance. Are they built in-house? Are they coming from the open source community? What type of tooling do you use for this automated maintenance?
Yeah, for the regular maintenance jobs that I mentioned, we use the Spark procedures that are available in the Iceberg repository. So yeah, are available to everyone. And actually, when we started, they were the only options that we had. Now we've seen this some of those maintenance operations implemented in other languages, but when Spark works well for us, and plus we have another team managing it. So that works. Plus,
and probably,
okay, sorry, go ahead.
And probably in the case of streaming use case that we are seeing more and more, such as the real-time use case that we've seen, it's more likely that we're going to support framing compaction as well, which has been a feature made available in Flink implementation as well.
Good.
Yeah, if I could add, like beside the regular maintenance jobs, we also added some maintenance tasks on our own. So we have some scripts that we wrote to, for example, restore tables that were deleted by mistake. Yeah, so like maybe a tip that from our early beginning when we didn't have all the safety mechanism in place. So now we enable soft deletes in every object storage to recover files that were deleted accidentally. And this comes from some lessons because that we had in the past.
Yes, incidents, those happen. Good. What about observability?
Yeah, so for observing Iceberg tables, we track 3 main areas. One, the first one, scan and commits. Those come directly from the Iceberg API. There is a metrics reporter API that sends certain metrics to the catalog, to the REST catalog, and then we send these reports using OpenLineage to the Datadog backend, and we monitor things like a number of scan files, the bytes that we read, also like how the duration of a planning and so on, like all the metrics that you can find in the metrics reporter API. Then we're managing a REST catalog service, so we monitor things like throughput, latency, but also Iceberg related stuff like commit conflicts that happen on a table. And then we also have observability on maintenance, of course, like, okay, how many files are we rewriting for compaction? How many snapshots are we removing every time? And then, yeah, here's a quick look of who uses our platform. We have mainly two categories of users: internal teams, internal engineering teams. These teams are mainly doing analytics, experimentation, and AI work. In their use cases, usually they query large data sets stored in the lakehouse, and they can pick the engine that they prefer. So yeah, Trino, Spark, Flink for ingestion, and so on, and Ray, as we mentioned before, for machine learning training. And then we have product teams. These teams build analytics directly into Datadog products. And like as Leo mentioned earlier, they join observability data with business data at large scale. And they run their workloads mostly using Trino, but they're also looking into data fusion.
So obviously, as a platform team, your customers are internal customers, as you mentioned, those two types mainly of customers. But as any team, do you offer guarantees to those teams, like through SLAs, or how does it work? That those contracts between you and those teams are your customers, basically.
Yeah, of course we have. As we manage a service as a REST catalog, we have some SLAs also coming from Datadog itself about latencies and availability. But we also have more other requirements coming directly from like querying Iceberg tables. So as I mentioned, we have some high volume ingestion and frequent ingestion in tables. They produce small files, and we want to ensure that the query performance on the read side are not bad because of the small files. So that's like, so it's
good. Good. So thanks. Before we go to questions, we're finishing, but I wanted to touch on open source. I'm part of the open source programs office here at Datadog, so something that it's I'm very interested in how we operate on those ecosystems, how we are part of those ecosystems, and obviously Apache Iceberg being open source, we've made some contributions back to that community, and I wanted to cover a couple of them, but I wanted to stop on this one on Azure support because Alessandro, as you mentioned, one of the key things about Datadog is we're running on multiple clouds. So why that effort to improve support in Azure?
Yeah, so when we started using Iceberg, we had some friction with using Azure and the authentication to the Azure Data Lake storage that we were using already in Datadog. So yeah, we spent some time contributing improvements to various implementation. Here we did Python, Rust. We also made some improvements in Java and Go. Yeah, especially personally, I've been more active in Iceberg Go. I enjoyed contributing there. But yeah.
So let's talk about Go. Let's talk about those contributions as well.
Yeah. Yeah, I mean, I'm in Datadog, we are heavy users of Go. Yeah, so like more and more teams are using Go. So we started seeing some, like Go was a little bit behind other implementation. And so we very recently started contributing more to Iceberg Go also.
Fantastic. I see those two contributions on the screen right now coming from you. So wanted to ask you about your experience on becoming a contributor of Iceberg, and any like if you have any suggestions for folks who might be interested as well.
Yeah, personally, I mean, I enjoy contributing a lot. And actually, before joining Datadog, I never done open source before. So for me, I started by joining the Slack communities, answering 2 questions that user had, looking into open issues, other open, and I found it useful to look for a good first issue. Usually there is a tag in these repos you can find. But yeah, you don't only contribute through code. You also can also contribute by opening issues when you find bug. That's actually very useful. We've also done that in the past. You contribute by doing code review, and yeah, there are multiple ways.
Yeah, there are multiple ways. Yes, I guess the recommendation would be to start like as you mentioned, being on Slack, seeing what people are asking, trying to answer questions, ask your own questions. So yeah.
There is also a mailing list, and where there are many topics that are being discussed, and Polaris and Iceberg and Polaris community are like small but very active with engaged main contributors, and it's really it's great because we can see features that we are also looking for in case of some of our use cases that are being discussed in RFC. So those are things that we can discuss openly and directly with them. For instance, there will be coming soon like single file commits or deletion vectors that could easier some of the use case that we have, which do streaming and update resource frequently, or things like governance features that could happen in Polaris as well, are things we are looking forward and discussing with the community.
Excellent. Good. Thanks both. Thank you. Now we are going to go for questions. But if you think that these problems and participating in open source communities and solving data problems at scale is an interesting career choice, Datadog is always hiring. So have a look to our careers page on that link. But now we are going to go for questions. So if you have any questions, if you are attending live and you have any questions, please use that Q&A button, and we will be able to tackle those. So while those arrive, I want to start to kick things off with one question, which obviously we've been talking a lot about platform teams and how your team owns the lakehouse and how you build SLAs for your customers, but it all seems like a little bit because of you are a big organization such as Datadog. But what about smaller teams and small companies? How do you see Apache Iceberg fitting in those organizations?
I think for a small organization, there are many vendors that allow easier journey into Iceberg. So there are things such as the Clue catalog along the S3 tables in AWS ecosystem that can work well if you want to get started with Iceberg and owning your data in your bucket. There are also vendors like Dremio that allows you owning your own buckets, your tables. Is also offering that has Snowflake more or offering to manage your own Iceberg table that you would own in your own bucket. So more vendors are providing that option if you don't want to have the friction of maintaining that the tables yourself. That said, to get started, if you have a catalog, the job maintenance at small scale is something that can be done for a small team as well.
Good. Do you want to add anything, Alessandro, to that one?
Yeah, I agree with Leo. Like, I probably if I had to start from a small team, I would use something that's managed at least at the beginning. Maintenance can be like maintenance is a critical piece. Of course, if you have very specific needs, you're gonna end up maybe running some you need data layout in different. You need to run some custom compaction, but yeah, other things like maintenance, expanding snapshot, or even managing a catalog service may be like a friction if your goal is just to provide business value.
Sounds good. So another thing, Alessandro, to get back to you. So you talked when you were talking about the REST catalog, the different implementations of the REST catalog, and Leo, you touch on the open source side of things briefly on Polaris. Can you tell us why you chose not to use it, and why you are now thinking about collaborating there to be able to use it?
Yeah, so I would go back in time when we I would go start from the beginning of the journey of Iceberg and Datadog. There were not open source Iceberg catalogs, so we had to make a choice of writing our own, and that's what was done at the beginning. And then we switched to JDBC catalog, which is an open source implementation, not of a REST catalog. And then after that, we put that behind the REST interface. But so open source catalogs are quite new, I would say. I think we saw the first major stable release of Polaris early this year. But now we started seeing the limits of our current implementation. Well, we didn't really hit the limit today, but we expect to hit those limits soon, and we're in the process of evaluating the switch to a new catalog.
Good. Anything to add there, Leo?
No, I think from the small market evolution, we did like Glue as the main use catalog right now, but it's not really an option in our case because we need to be vendor agnostic, so our cloud as agnostic mostly. So in our case, we have the options mostly Polaris, like Keeper and Unity available as like strong catalogs today. And it's not easy because indeed they for some of them they just came out in their first major version, so it's not exactly easy at this point to see where the open source community will going to converge at some point.
Yes, when you touch on something that it's for me, it's very interesting on how platform teams at Datadog operate, because as you mentioned, we are multi-cloud, and we need to make sure that teams can deploy the products regardless of the cloud, and I really love how platform teams at Datadog, one of the things that they do is to make sure that the interfaces that people see, the rest of the teams see, are the same regardless of the cloud. And I think, and as we've seen today, is the case for your team as well. Cool. So I don't think we have any other questions, so I think we can wrap it up here. Thanks everyone for joining live. This was great. Thanks Alessandro and Leo for sharing the knowledge.
Yeah.
And someone is asking on the questions as well. Yes, this is being recorded. So check out Datadog on datadoghq.com in a few days, and the recording will be there. So thanks very much.
Thank you.
Thank you.
Thanks. Bye-bye.